So far, you've learned how to solve systems of equations that involve two linear equations, or two graphs of two linear equations that intersect at some point, and that point is the solution of that system of equations. Sometimes, however, you might find that you have a system of equations in which one of the equations or functions is a linear equation and the other is a quadratic equation. The way to go about solving these graphically is quite similar. In a system of equations where one of your equations is a linear equation and the other is a quadratic, you still look for the intersection point of the graphs to see what are the solutions of this system of equations. Where those graphs intersect, that is where the input values give you the same output values for both functions. Since this time we have a quadratic equation involved, unlike a system of two linear equations, instead of just having one solution point, there's a good chance you may find that you have two solution points to the system of equations. Also, similar to last time, however, if the quadratic equation does not ever intersect with a linear equation, you might have no solutions to the system. Or if somehow the quadratic equation is tangent to the linear equation and only meets at one point, you may only have one solution to the system of equations. Let's take a look at an example. What are the solutions of the system of equations pictured in the graph below? Select all that apply. So we have a linear equation that we see over here, and then we actually have an equation for an ellipses that you see over here. And to find the solution to the system of equations, we're looking for where do the two graphs intersect. And you can see right off the bat there are 2 points at which they intersect. And those points are 5, 4, and -4, -5. Those are the two solutions to the system of linear and quadratic equations in this scenario.